Good morning children. Today we are going to take a new chapter, arithmetic progression. First of all, you should learn about what is sequence. Sequence means a list of number which is arranged in definite order according to definite rule. A list of number which is arranged in definite order according to definite rule. So here there is certain examples. Example 1, 10, 12, 16, 100. These are arranged and the rule is ascending order. And the second example is 1, 2, 3, 4, 5, etc. is also arranged and the rule is the numbers are obtained by adding 1 to the preceding number. And the example 3 is 2, 4, 8, 16. These are well arranged and this is obtained by, each numbers are obtained by multiplying 2 to the preceding number. And each number in the sequence we called it as terms. So these are sequences and in the first sequence 1, 10, 12, 16, hundreds are, we called it as terms. Here 1, 2, 3, 4, 5 are the terms of this sequence. 2, 4, 8, 16 are the terms of this sequence. Next is progression. Progression means those sequence who should always follow certain pattern. Progression means it should be a sequence and it should follow certain pattern. Examples, first one 3, 5, 7, 9, etc. Here this except first term, the next 3 terms are obtained by, here 3 plus 2 is 5, here 5 plus 2 is 7 and here 7 plus 2 is 9. So there is a pattern. So this one is a progression. And each terms are obtained by adding 2 to the preceding number. And here the second example 3, 10, 21, 35. These are sequence but it's not a progression because there is no any pattern. This one is a sequence but it's not a progression because there is no any pattern. So next is our main topic, arithmetic progression. Examples 1, 2, 3, 4, etc. Second one 100, 70, 10, etc. Third one -3, -2, -1, 0, etc. Fourth one 3, 3, 3, 3, etc. All these examples are sequences because it has definite rule and it is also a pattern, so we can call it as progression because since here 1, 2, 3, 4, etc. is obtained by adding 1 to each terms. And here 100, 70, 40, 10, etc. also a progression since 100 plus minus 30 is 70 and here 70 plus minus 30 is 40 and here 40 plus minus 30 is 10. So this one is also a progression. Here -3, -2, -1, 0, etc. is obtained by -3 plus 1, here -2 plus 1 and here -1 plus 1. -1 plus 1 is equal to 0, we all know. Next is 3, 3, 3, 3, etc. This one is also a progression since 3 plus 0 is 3, here is also 3 plus 0, here is also 3 plus 0. These are arithmetic progression. The reason is these are progression and each terms are obtained by adding a fixed number. which means arithmetic progression is a list of number in which each terms are obtained by adding a fixed number except the first term. This one is the definition of arithmetic progression. A list of number which is obtained by adding a fixed number to the preceding number except the first term. And arithmetic progression, we called it as AP. And here we call the fixed number as common difference. And we denoted it as D. So, arithmetic progression is a list of number which is obtained by adding a fixed number to the preceding number except the first term. And the fixed number we called it as common difference and denoting D. Here these are arithmetic progression because in each term is adding by a fixed number. Here the fixed number is 1. We are adding 1 to the preceding number. So, we can take 1 as the common difference. In second one, D is minus 30. Third one, D is 1. And for the fourth one, D is 0. So, I think it is clear what is common difference. Okay, we know the common difference, and the common difference should be positive, negative or 0. It can be positive number or a negative number, and 0 is also maybe a common difference. And next is in an arithmetic progression, if terms are finite, then it is finite arithmetic progression. If the terms are finite, then we can call it as finite arithmetic progression. If the terms are infinite, then we can call it as infinite arithmetic progression. If A1, A2, A3, A4, etc., An is an arithmetic progression and D is the common difference, we can write A1 is equal to A1, A2 is equal to A1 plus D, A3 is equal to A2 plus D, and A4 is equal to A3 plus D. We are adding the fixed number because it is an arithmetic progression. We can write like this. And also we can write A2 plus D is equal to A1 plus D plus D because A2 is equal to A1 plus D. So, we can write instead of A2 A1 plus D plus D. So, this one is A1 plus 2D. A4 is equal to A3 plus D. Instead of A3, we can write A1 plus 2D. So, it becomes A1 plus 2D plus this D. So, it becomes A1 plus 3D. Likewise, we can write A5. Here, A3 is A1 plus 2D and A4 is A1 plus 3D. So, A5 is A1 plus 4D and A6 is equal to A1 plus 5D, etc. So we can form a general form of an arithmetic progression by, here the first term is a, instead of a1 I am writing instead of a1 a as the first term, and then the second term is a1 plus d. Instead of a1 I put a, so it becomes a plus d, and a3 a plus 2d, and fourth one a plus 3d, etc. So this is the general form of arithmetic progression with first term is a and the common difference is d. So this is the general form of arithmetic progression a plus d, a plus 2d, a plus 3d. Here the first term is a and the common difference is d. So I think you all understood what I am saying, arithmetic progression, what is arithmetic progression and the general form. This is the new topic and I think all of you should understood.